Hello everyone, my name is Manmohan Bandhan and we are back with one more video. So this video will be on left view of a binary tree. As you can see, it's a very medium kind of question available on both GFG and in some another manner in lead code also. So this question will use some prerequisites of level order traversal. So we'll first learn what is what the question wants to say to us, what is the left view of a binary tree, and then we'll connect it with we'll find its connection with the level order traversal, and then I'll leave you with one follow-up question, which is a binary tree right side view, which is available on LeetCode. So let's get back to my OneNote. So here, this is a binary tree. The root node is 1. As you can see, the left children of 1 is 2 and the right children is 3. Continuing, the left children and right children are 4 and 5. And for 3, the left children and right children are 6 and 7. And 7's left children is 8. So what will be the left view of it? Like if the question wants us to print, if we are looking, we are seeing this binary tree from this side, so what will be our view? Like how what will we see? So first we'll see 1, then 2, then 4, and then 8, because there are like no nodes in front of 8, because we are seeing in from this left side, so there are no nodes in front of 8, so we like 8 will be visible for us if we are seeing it from the left side. So we have to print 1 2 4 8. Note that we have to print like from top to bottom. We are first 1, then 2, then 4, then 8. We have to return this array. Like what will be the left view of a binary tree? So let me explain one more test case. This test case was given in the question itself. So what will be the answer? Obviously it's easier than this one. So our answer will be, you can see the left node, because in this level the first node is 1. So my first element of the answer vector will be 1. Then second, for this level, we can't like take 3, because 3 won't be visible, because 2 is in front of 3. So 2 will be our left 2 will come in the left view of the this binary tree. Similarly, we won't be able to see 5, 6 and 7. They won't exist in my answer. Why? Because there exists a node 4 which is in front of all three, which is covering them. So we will only able to see 4. So 4 will be added to our answer, and similarly for this level our answer will be 8. So this will be our final answer vector for this question, this test case. As you can see, 1 2 4 8, left view of this binary tree will be 1 2 4 8. So how will we calculate that? So as I said earlier, this question you needs some prerequisites of level order traversal. That's why Ishika made a video today's morning already on level order traversal. So I assume you guys know about the level order traversal. So now think about what are some patterns we can see here. Think develop an intuition. We can see here, for each and every level we are only able to see the first element, the first node which is coming. For every level, the first node which is coming, we have to take that node, because you guys can see in this level 2 is coming in front. So 2 will be our 2 will be in our answer vector. Next, in this level, while traversing this level, we can see 4 will be the first node in this level, like traversing from left to right, as you guys know, we traverse from as like left to right. So in this level, 4 will be our first node, and similarly in this case, 8 will be our first node. So this will be the zeroth level. This will be the first level, second level, and so, okay, I guess there is some issue. Okay, okay. So continuing that. Mhm. So 4 will be the first element of this third level. This is the third level, and for eighth will be, sorry, this will be the second level, and eight will be the first node of the third level. So we just have to perform a level order traversal on the whole binary tree, and we just have to take the first node coming from left to right. So we'll take the leftmost node in the in our level order traversal. So that will be our answer. So now, how I guess now logic is clear. In case of any doubt, you guys can comment on the comment section. So here, okay, okay. So in order to like how we find level order traversal, you guys already know. But uh, if you guys remember, in level order traversal, we are able to detect when our level is changing. So throughout the level order traversal, we just have to detect whenever one level has been changed, we will take the upcoming node in the level order traversal. For an example, if we perform a level order traversal here, so the first level will contain 1, the second level will contain 2, 3, the next level, the second, this is the zeroth level will contain 1, first level will contain 2 and 3, the second level will contain 4, 5, 6, 7, and the next third level will contain 8th node. So we need to develop a logic in which we are able to detect these breaks. Like whenever a level changes, we just need to detect that, and will print the first upcoming node. Like here, after this level change, we'll print 2. After this level change, we'll print 4, and after this level change, we'll print 8. So similarly for here, 1, 2, 4, and 8. So now what I will do is I'll put a null in my queue. As you guys know that we perform a level order traversal using a queue. It's basically like a BFS. So we perform it using a queue. So what I do is I insert a null in after traversing a complete level, and as soon as a null I detect a null in the front of a queue as a frontmost element, so I can say that my this level has been completed, and I just have to print the upcoming node which will come after null. So uh, now we are ready to code it. So here, okay, let me just increase it's already on the max in this. Hmm. So what we will do is we'll first if we'll okay, is there any condition of zero node? Yes. Okay, check specifically if there is a condition of zero node, that number of nodes can be zero. Check the constraints for it. So all we can write a complementary statement like root if not root, basically if root is equal to nil, we can just return an empty vector. it basically means that our tree is pointing to null, so it has zero nodes, so we'll just return the uh, empty vector. So now we are ready to perform our level order traversal. So I'll just take a queue, and after taking this queue, I'll push the root. Okay, it should not be int, it should be a node star. So I'm taking a root, the root element, and as we know, the root element is the on the first zeroth level, it only the binary tree contains only the root element. So I can say that this node, this level has completely been processed. So after this, I'll push a null, and also okay, I'll take first an answer vector. It is important to write some readable code, so it will it will develop a good habit if you take variable name as something answer and count something. It's basically a good practice to code. So we'll take an answer vector, and after this I can perform the breaking condition for the while loop will be until my queue is not empty, until my queue contains at least one element. This process should continue, and after this I'll return my answer vector. Okay, so what will we do inside this while loop? we'll first we'll first take the frontmost element of our queue. So I'll call it as a temp, and I'll take q dot front, and after reading it from the front, we can pop that element. I'm coding it in C++. You guys can those who are familiar with any other languages can implement it at their own. But I guess I develop I am able to make you understand the algorithm. So I'm continuing with C++. So we'll just pop the frontmost element from the queue, and after popping it, we'll process this element. Like if this element, this temp, if it's null, then we'll do some operations. If it's null, then we'll do some operations, else we'll do another set of operations. So here we can say that I first inserted root, so root will not be empty. So I can insert all of its child in the queue, but for that we have to just check if left child, because we don't want to insert null explicitly, implicitly. So I'll will just check it's if temps left child exists, then we'll push temps left to the queue, and similarly if right children of temp exists, so we'll also insert the right children of the temp. So in with this procedure, what will happen? I first inserted, this is my queue, this is my queue. So I first inserted 1, and then I inserted a null because my level has completely been processed. So I first inserted 1, then null. This is my queue. So what will happen, as we'll take the frontmost element, which is 1 in this case. So I'll just because 1 is not null, so I'll just insert its left and right children in queue. So I'll insert 2 and 3. After this, 1 will be removed. So in the next traversal, we will see that a null came. So when the frontmost element of our queue is null, so we can say the current level has completely been processed. And if we are ready to say that the current level has completely been processed, then it's pretty sure that the current levels all children has completely been inserted in the queue. So basically the next the next level of this current level has completely been inserted in the queue. So I can like one null says that we can insert another null because the next level has completely been inserted in the queue. So as we can see, like after null, it basically shows that once all children has completely been inserted in the queue. So I can insert one more null after this, and I'll just pop this pop this current null. So if my temp, basically the front post element is null, so I can push one more null. Basically it means that the next level has completely been inserted in the queue. Following this, when we will traverse the front post the 2, basically it means that we are on the next level. So I'll process 2 and insert all of its children, then 2 will be removed, then I'll I'll process 3 and all of its children will be inserted in the queue, and then we'll remove the 3. Now again we can see also here the front post element is now null, and this null basically means all the previous element the which were existing in the queue has already been completed, has already been processed, and all of its children has already been inserted in the queue. So we are sure that the next level, this 4 5 6 7, this second level 0 first second, the second level of this binary tree has completely been inserted in the queue. So I'll just put one more null in the end. Now again with process when while processing 4, it will just process all of its children, basically 8 and 4, because 5 does not have any children, so 5 will be removed. 4 be 4 5 6 7 completely. And after this, okay, let me bring them forward. What will happen after this? We can see here, when we are processing this null, so we can say the above level sorry the next level current to this level, next to this level has completely been inserted in the queue. So I'll just put this null, basically indicates the to insert one more null in the queue. So I'll just insert one more null, and after this I'll process 8 because just because 8 does not have any children, so 8 will be processed. And at this case, this is the a very minute case which can give you a runtime error. See, now my tree has completely been processed, and this is a my current current element. So what will happen if I'll see this null? So what we were doing back is, after popping a null, we were inserting a null again. But now what will happen, after removing this null, we'll insert one more null, and after removing this null, and this will go on, and this will give me a time limit error. This will go on and on. So it will give you a TLE. So we need to avoid this edge. So what we will do is, after reading the front element, we will as we are popping the element, and after popping it, we'll just check that if my queue is currently empty, then we don't have to put more nulls in my queue. So basically when we were suppose after you guys can remember, after travel processing the zeroth level, my queue was like this. My queue was like this. And why like after reading this null, we inserted one more null because my queue was not empty. It was containing two elements, 2 and 3. But after processing this last null, this null, we won't insert any more nulls because my queue gets empty. So to avoid a TLE, we'll just like check if not of queue dot empty, then only then only insert this extra null. So this was the basic level order traversal, and now we need to find the we are now able to detect every level change. So we'll just take the first element coming in the queue after a level change. So what we'll do, I'll just take a boolean variable, which is this, and I'll just give like after a level change, I'll just mark it as a true, and my code will check if t is currently true, then insert the upcoming node in my answer vector. And after inserting it, I'll again mark t as false so that it don't inserts the next upcoming nodes also. So what we will do after doing this bool t is equal to true, I'll just check here if my t is currently true, then insert the current frontmost element in my like answer vector. So it will be temp data, and after this I'll just mark t as a false, so it won't insert any null values or any other values than answers to in the my answer vector. And after we detect a null, so what was our null was basically detection of our level change. So after as we will like detect our level change, so we'll just mark t as true again. So I hope you guys are clear with the code. Let's compile it. So here you guys can see compilation successful. So now we are submitting it. Okay, so you guys can see here so this was my approach to this problem using level order traversal. We just performed a level order traversal in this binary tree, and we take the first element of every level. So I'm leaving you with one follow-up question. This question is about binary tree right side view. We basically performed here a left view of binary tree. This question is all about the right view of a binary tree. So you guys need to code this and do leave a comment that I have solved this problem. So I will wait for your comments, and do try this problem because this is also like similar kind of problem. Basically we need to you guys can see we need to basically detect the last node before our level change. So similar code will be like a similar approach you guys can try. So thank you. We'll come again, we'll return again with one more question. Thank you so much for today.